Another successful launch of the Shuttle orbiter Atlantis as it speeds to the International Space Station, and another job well done by the dedicated individuals on the ground whose job it is to ensure the safety of the crew and vehicle. A task which requires commitment, innovation, and a great team effort to ensure critical issues never adversely affect a successful launch like this one. However, a critical issue was just recently discovered when tin whiskers were found inside the flight control system's line replacement units, which are critical to maneuver the vehicle during space flight. What are tin whiskers? Tin whiskers are electrically conductive crystalline structures of tin that sometimes grow from surfaces where electroplated tin is used as a final finish. First documented in the 1950s, tin whiskers are considered a phenomenon. They can cause serious electrical shorts and system failures. The elongated single crystals of pure tin have been documented at 1 millimeter or less in length, but the tin whiskers found in the LRUs by NSLD personnel were as long as 18 millimeters. The unpredictability of tin whiskers makes it even more difficult to detect and eliminate. It may begin soon after initial plating, or it may take years. In either case, a group of dedicated individuals at NASA Shuttle Logistics Depot at Cape Canaveral, Florida, are doing everything they can to ensure this version of foreign object debris does not threaten the Space Shuttle program. After the initial tin whisker findings, it had to be assumed all of the 52 units from the fleet could be contaminated and were immediately scheduled for disassembly and inspection. Faced with the challenge of how to handle the task of removing the tin whiskers from the flight hardware, a detailed plan was devised to disassemble, clean the tin whiskers from the LRUs, reassemble, and test each unit. USA went to Honeywell's Florida and Arizona facilities for the additional manpower needed to complete this task. With the normal annual repair rate of 1 or 2 units, the avionics technicians were set with the challenge of repairing all 52 units, an unprecedented volume for the NSLD. Effort was put into assembling an additional manual universal test set used to perform acceptance testing. Assembly of the second manual universal test set was in itself a significant task. Many scarce items had to be located, procured, assembled, and tested to bring this critical system online and operational. Although the tin whisker phenomenon has been known in the electronic industry for some time now, there is very little documentation on how to remove tin whiskers and clean the contaminated components and hardware. Like most Space Shuttle hardware, the LRUs are irreplaceable, so the only option was to disassemble the contaminated LRUs, clean the tin whiskers, and remove and replace the tin-plated card retainers. One of the key aspects of disassembly was concern for contamination of other flight hardware or flight hardware processing areas. Whiskers will become airborne and infiltrate air systems, causing contamination of widespread areas. As a result, the LRUs were to be disassembled in fume hoods to minimize whisker contamination and to isolate the rework from other flight hardware processing areas. Another concern was the original conformal coating was sprayed onto the surface of the cards, and due to a shadowing effect, not all surfaces were properly conformal coated. So theoretically, it would be possible for a tin whisker to short unprotected terminals of these components. Boeing M&P provided support for determining the right viscosity and application technique for the conformal coating to properly coat the terminal. The card retainers were originally installed prior to the internal components, so access to the card retainer hardware in these tight areas of the LRUs are impossible without the newly developed special tools to accomplish this very difficult task. During this teardown process, it was imperative the wiring not be disturbed. The cleaning and removing of tin whiskers with best results was blowing GN2 at a 45-degree angle using an air ionizer blowgun at 50 psi to avoid impinging tin whiskers onto the surface of the circuit cards. Tight controls and the use of special ionized equipment were required to significantly reduce the risk of electrostatic discharge damage to our sensitive electronic equipment. The LRU chassis were much easier to clean. The tin whiskers were vacuumed from the chassis, then cleaned by hand with isopropyl alcohol and lint-free cloth. Following cleaning, both the circuit boards and LRU chassis were thoroughly inspected for any remaining tin whiskers. To reduce the fatigue caused by 10-hour days, 6 days a week inspection, an ergonomic-friendly microscope station was purchased to improve the inspection process. Next came reassembly for the refurbishment and now safe LRUs. New card guides were needed without the tin coating. Procurement was able to arrange delivery of critical components, many material and engineering issues were solved, and Honeywell delivered over 1,200 new card guides. Next came the intensive testing, with over 6,000 functional tests on each of the vibe and thermal stations. As evidence here of the vibe table shaking the LRU. The LRUs are again put through the stringent tests of the manual universal test set to ensure complete and correct readings for 100% accuracy. With the LRU rework almost completed, the Tin Whisker effort has been quite a learning experience and a complete team effort between NASA, USA, Boeing, and Honeywell. The dedication and know-how to get the job done, along with much help from all departments and services, we at the NSLD were able to solve such an incredible and most important issue. All for our common goal, astronaut safety and mission success.